Hey guys, this is Miss Sarah. I'm back with my next lesson, and today's lesson is A-3, which is on page number 530. Okay, so in this section, we're going to be learning about integral of log functions. Okay, how do we do integral of log function? So just with the way we always do it in class, so I'll show you derivative part first, and then we'll try understanding the pattern and we'll do integral from there. So if you remember, derivative of any log function, it's always equal to 1 over the function. If it's derivative of a function other than x, which is, let's just say it's u, then it's going to be 1 over u, and it should have derivative of this bottom part attached to it, right? That's derivative. Now on this side, I'll show you integral. Integral. All right. Now, since we are actually undoing this process, so it means you'll see 1 over some function. If you see that 1 over that function, it means this is going to be integral of ln function. This is going to be ln x and plus c. Now, there's something we're going to do slightly different here. I'm just going to put absolute value symbol around x. Why? Because you know ln can be in a negative ever, so this is just going to be a positive. And let's say you have 1 over u, which is different function than x, means it's going, first you need to complete the pattern, means you need to make sure it should attach with its derivative. If it is, then this derivative would just go away, and the answer would be ln of u and absolute value and plus c here. Once I'm going to show you example, I hope it will make more sense. So let's look at the first example. So first example, I have integral of 2 over x and its dx. Now some of you guys might gonna think, like, when I look at this problem, it looks exactly like normal integral problem. Like, how would we be able to differentiate if this is log function integral or normal integral? Let me show you something. Let's just pretend this is like normal function. I'm integrating. Normally, what we do is we take, because we do not have any quotient or anything, product rule, anything like that, what we could do is we could just take this x to the top. Okay, now try doing normal integral. For normal integral, what we do is we add 1 and we divide by the same thing. Oh, let's see what happens if I do this. -1 plus 1 is 0, so this becomes 0. And now it's dividing by 0, which makes this function undefined. Here you go. So that's a clue. Anytime you try doing normal integral to that function, it becomes undefined at the end. So it means this is definitely going to be integral of log functions. This is not normal integral. This is integral of log function. So like here, I know this is going to be undefined, so this is definitely going to be log function. So first, I would try factoring out the constant just to see 1 over the expression. I would factor out 2. I have 1 over x left. Now I know I have 1 over x, which is same as ln of x, and I would just add c at the end. Again, anytime you see 1 over some function, if it already has its derivative attached to it, just complete the pattern and just say ln of that function and add c at the end. Here you go. Or there's another clue. Anytime the numerator degree is less than the bottom degree, that's just another clue to find if it's integral of log function or not. Okay? Let me show you one more example. So let's say I have integral of 1 over 2x minus 1 and dx. Okay. I see a fraction for sure. The bottom one is bigger, bottom degree is bigger than the top one. So this is definitely going to be log function. But I need to double check. Is the top expression derivative of the bottom one or not? For that, I'll just find the derivative of 2x minus 1. What's the derivative? Derivative is 2. Oh, this one doesn't have the derivative, so it means I need to bring in the number, so I would bring in 2 over 2. This top 2 would complete the pattern. Factor out 1/2, so this is going to be my original function. I would just put ln of 2x minus 1 and add c. Here you go. Okay, another one. Let's say I have integral of 3x to the second plus 1 over x to the third plus x and dx. The top degree is less than the bottom one, so it's definitely going to be ln function, but I need to double check. Is the top expression derivative of the bottom one or not? All right, derivative of this. Let's check. Derivative would be 3x to the second plus 1, which is same as this, so it means it would be, there's nothing I need to factor out, there's nothing I need to bring it in, so this is right away, it's going to be ln of the denominator function. And I would add c at the end. Here you go. One more. Actually, a few more. I have x plus 1. This is example number 4. I have x to the third plus 2x, and it's, oh, this is not 3. This is 2. Okay. Again, it's a fraction. Top is less than the bottom one, so let's just find the derivative. Derivative of x squared plus 2x. Let's check. It's equal to 2x plus 2, which is not same as this, but I know if I could factor out a 2, it would become same as that. So this is where you need to bring in the number, so I would bring in 2 over 2. This top 2 and x plus 1 would complete the pattern, so I would factor out 1/2, so this is ln of x squared plus 2x, and add c at the end. Now, last example is about definite integral. This is example 3 on page 531. So this is definite integral, and I hope you remember definite integral is where you actually find the value. You evaluate the area. This is where you see two numbers on this integral. So let me put up the problem. I have x over x squared plus 1. This is 3, this is 0, and dx. So top degree is less than the bottom one, so I know it's going to be integral of log function. So let's just find the derivative of the bottom part. Derivative of x squared plus 1, it's going to be 2x. So there's 2 that's missing, so I would bring in the number. So I would bring in 2 over 2. This top 2 and x would complete the pattern, so I would factor out 1/2. So this would give me ln of this bottom expression, which is x squared plus 1. Oh, this time I'm not adding c to that because I know I need to evaluate this function for 3 and 0. These two limits. So let's just plug it in. So 1/2 would stay the same. So the first, let's plug in 3 into this function. So 3 squared 9 added to 1, 10. So it's ln 10. Minus, now I would plug in 0 in here. So 0 squared is 0 added to 1. It's 1. So it's ln of 1. Now you can plug it. You can use your calculator and evaluate each one. So 1/2. ln 10 would stay. Like you can still plug it in your calculator to get a value. ln of 1. I don't know if you remember one of the property. It's always equal to 0. So this is going to be 1/2 ln 10. And if you put in your calculator, this is going to be this answer. Here you go. So that's how we integrate log functions. So again, the idea is it has to be a fraction. But if it looks like normal function, you could always try doing this. If you take it to the top and the bottom becomes 0, and if it becomes undefined, so here's the clue. That's the clue that it's going to be log function integral. And rest is pretty much just following these examples. And if you need help on anything, please send me a comment. I'll just answer that question. And thank you for watching. Bye-bye, guys.